when the parent geometry is trigonal bipyramidal and we have two lone pairs, then we have a T-shaped geometry. Hello everyone and welcome to my channel. Today we again have a VACPR based question which says the species that has T shape. Okay, so we have to identify amongst the given four molecules which one of these have a T shape. And in addition to finding which one of the molecule has a T shape, let's find out the shapes of all the given molecules. Let's do that. So first of all, we have to find out the total number of electron pairs in that particular molecule, which is the sum of the valence electron of the central atom. In PCl3, the central atom is phosphorus. So it belongs to the nitrogen family. And the number of valence electron in phosphorus is 5. And how many chlorine atoms are bonded? So the number of electrons contributed by the neighboring atom, that is 3 chlorine atoms. So each contributes 1 electron. So 5 plus 3. And since we are finding out the electron pairs, so divide it by 2. And we get 4 number of electron pairs for PCl3. Now, the number of bond pairs. How many atoms are bonded to the central phosphorus atom? So, 3 chlorine atoms are bonded. So, number of bond pairs is 3. And what are the number of lone pairs? So, total number of electron pairs 4 minus number of bond pairs 3. That is equal to 1 lone pair in PCl3. Now, the molecule which has 4 number of electron pairs, that parent geometry or the electron geometry is tetrahedral. So I am indicating it by TD, tetrahedral. But when we have one lone pair in a tetrahedral parent geometry, then the molecular shape becomes pyramidal, trigonal pyramidal, just like ammonia. So something like this, the pyramidal structure, and on top we have the lone pair on phosphorus. So this is the PCl3 trigonal pyramidal structure. Now coming to SOCl2. So which one of these is the central atom? Between sulfur and oxygen, sulfur is the central atom. Why? Because when we have only one atom, then we have to decide based on the electronegativity. That also we have discussed in my previous videos. So sulfur has a lower electronegativity. So this one is the central atom in SOCl2. Okay, sulfur. So what is the number of valence electrons? Sulfur belongs to oxygen family. So 6 for sulfur. Then oxygen we will not consider here because oxygen could be double bonded. So we leave this contribution in the total number of electron pairs. So 6 plus 0 and 2 chlorine atoms bonded to sulfur. So 2 electrons contributed divided by 2. Again the number of total number of electrons for SOCl2 comes out to be 4. 6 plus 2 divided by 2. 4 number of total electron pairs in SOCl2. How many number of atoms are bonded in SOCl2? So 1 oxygen atom, 2 chlorine atom. We will consider the contribution of this oxygen because we consider the contribution of the sigma bonded oxygen. One of the bonds is a sigma bond even if the oxygen is double bonded. We consider its contribution in the bond pairs. So total 1 oxygen and 2 chlorine atoms. So 3 bond pairs. Okay, number of lone pairs. So we subtract total number of electron pairs, which is 4 minus 3, that is equal to 1 lone pair. When the total number of electron pairs is 4, the parent geometry is tetrahedral, just like PCl3 we saw in option A. So tetrahedral geometry with 1 lone pair gives us the pyramidal structure for SOCl2 as well. So something like this is the structure of SOCl2 with 1 lone pair on top and 2 chlorine atoms and a double bonded oxygen atom. Now let's move on to option C, which is BrF3. Now the valence electrons in the central atom bromine. So bromine belongs to the halogen family. So 7 valence electrons in bromine and then 3 electrons contributed through 3 bonded fluorine atoms here. So 7 plus 3 divided by 2, that is 5 number of electron pairs. So total electron pairs in BRF3 is 5. Okay. And that gives us the parent geometry of TBP, trigonal bipyramidal. Now, how many number of bond pairs in BRF3? So, 3 fluorine atoms are bonded to the central atom bromine. So, 3 bond pairs, and how many number of lone pairs? 5 number of total electron pairs minus 3 bond pairs. That is equal to 2 lone pairs for BRF3. Now, when the parent geometry is trigonal bipyramidal and we have 2 lone pairs, then we have a T-shaped geometry where the lone pairs are arranged equatorially. The bromine lone pairs are arranged equatorially, 2 lone pairs, and 2 fluorine atoms are axial here, and 1 fluorine atom is equatorial. So it is basically a TBP geometry, parent geometry, but due to the presence of 2 lone pairs, this perfect trigonal bipyramidal geometry is distorted to a T-shaped geometry, which looks something like this. So the molecule that will show T-shaped geometry is BRF3 in this question. Option C is the correct answer. Okay, now since we are finding the shapes of all the given molecules, let's move on to IO3 minus option, which is option D. Okay, IO3 minus. So total number of electron pairs. Which one is the central atom? Iodine is the central atom belonging to the halogen family. So 7 valence electrons. Then we do not consider the contribution of the double bonded oxygen here, and we have a negative charge as well. So 7 plus 1 negative charge divided by 2. So we have 4 number of electron pairs in IO3 minus. Now, number of bond pairs here. How many oxygens are bonded to iodine? 3 oxygens. We consider this contribution of 3 bonded oxygen atoms because even if they have double bonds, one of the bonds in those double bond is a sigma bond. So we consider this contribution of the bond pairs. So 3 oxygens, 3 bond pairs. Now the number of lone pairs. So we subtract 4, that is total number of electron pairs, minus 3 number of bond pairs. So the total number of lone pairs is equal to 1. Okay. Now when we have the total number of electron pairs equal to 4, then we very well know the parent geometry will be tetrahedral, TD. Okay, but when we have lone pair in this tetrahedral geometry, then it gets distorted to give us the trigonal pyramidal geometry. So we have trigonal pyramidal geometry for IO3 minus as well, where we have this kind of structure. The lone pair is on top of that tetrahedral structure, and then we have 2 double bonded oxygen and a single bonded oxygen. Charge on the molecule is minus 1, so we can put it outside the brackets, and we have 3 bonded oxygens in a trigonal pyramidal shape. So we have found the geometry, molecular shape of all the given molecules, and also the answer to the question that which among these have a T-shaped geometry. So BRF3 is the molecule that will show T-shaped geometry. So I hope this explanation was clear to you, and also the principles and the rules that we apply for solving this type of questions using the VA-CPR theory. Please do not forget to like, share and subscribe if you find my videos helpful to you. Till then, keep learning, keep watching, and see you soon with the next problem.